This is a demo for vector-based real-time content recommendation system. So let's start with logging in to our solution. Yeah, we can see in the dashboard it shows all the content that we have. So let's see one of the news. So as soon as we click on the news, we have our recommendations ready. We see that the recommendations are kind of real time, but how to prove that? So what evidence do we have that it's real time? um, okay, so before that, let's verify that our recommendations are working fine. So this news is based on UK riots. The recommendations are protest and deep-rooted anger, um, rioters in the UK, 900 arrests after far-right demonstration. It's obviously um, based on UK. Yeah, so we can see um, um, the recommendation is very trustworthy. um, yeah we can also see we have variations in news, like we have news from CNN, BBC, and CNN as well. Let's search for any other topic like US election. Okay, let's go to any of the news. So this is based on um, um, the UK election. Harris holds up, Kamala Harris picks up the Tim Walz as running mate. So yeah, we can see the recommendation matches the article that we are reading. Okay, we can also search with natural terms like give me some funny news. Let's see some title. An AI walks into a bar can generally be funny. Tiffany Hardy's defends Zimbabwe after backlash. I'm not sure how this is funny. Among winners of TikTok book hours. TikTok is always funny. Yeah. Um, I got malaria in medical trial and found. Yeah, this is kind of funny. Um, and yeah, we can see the search terms um, can be somewhat natural. Let's try the image search. So for the image search, I have used ImageNet, which is um, which is basically best working for faces or any other anchors that we have. So let's find some. Yeah, let's go for this image. Yeah, copy image address, and if we search by the image URL, let's remove all the query parameters. We can have some faces, but not exactly that one. There's room for improvement. Let's take this image, copy image address, and paste this one. Yeah, so based on image quality and face in the image, we can have pretty good result or pretty bad result. Okay, yep. Sorry. um, uh, the image, this is a demo for um, image search. So but for production, we will basically have some alt tag generators, um, or object detector, like object recognition engines. um, yeah, so let's see how the backend works. So we can um, in scrap news from BBC and scrap news from CNN. So if we run the scraping, it basically grabs all the news from the homepage of each news portal and scraps the result into the content database. So for vector database, I have used pgvector among many other solutions like Neo4j, Qdrant, I chose pgvector because it's convenient, and we can also um, we can also have the conventional database alongside the vector database, which will increase the productivity somewhat. Okay, let's so this is the day one part. We have developed the application, we deployed it. Now what to do with day one solution, like how to monitor it, the tracing solution and all. So for that we have open telemetry in place. It's backed by CNCF and widely accepted. So the current solution is actually deployed in Kubernetes. So we have um, so let's see. Um, let's go into the Rex namespace. We have Nats. Nats is it's basically our PubSub provider. The solution is event driven. So Nat is basically providing the image bus, message bus. Ollama is used for the vector embeddings, and yeah, it's used for vector embeddings only. Postgres is our database. We have pgvector extension enabled in the Postgres. API provides the paginated news and search functionality. Um, uh, it's the Istio gateways. The embedder provides the text embedding functionality. So if we put any text, it will return back the text vector. So for now we are using MX by text embedder. It returns 1024 arrays of the text given. The image descriptor is using ImageNet for generating the image vector. The spider is our scraper. We are using Collie to concurrently scraping. So this is very time as well as space efficient. So the whole stack is written on Python and Go. Um, so most of the cases I have used Go for the concurrency um, and the machine capacity, to be honest. Only for image descriptor we have used Python. Uh, okay. Um, and the UI is written in Vue.js. Let's let's see some of our deployments. We are using Grafana. Istio is the data plane of Istio, Jaeger, Kiali, and Prometheus. Um, so Jaeger and the Kiali provides us with day one solution, like how our application is working. Can we deploy other versions of application? There is a demo. How can we deploy in Canary? So yeah, so let's see what Kiali gives us. So let's see for the 10 minutes. So as we can see, we have all the stack here. So this is in text embedder. Text embedder is calling image embedder, and so on. um, yeah, we have Rex Spider, Rex API. Let's enable response time to see what's happening underneath. So yeah, so we have 381 milliseconds for the recommendation API, like generating recommendation and creating new news. If we see 50th percentile, like P50%, we will have a much nicer view. So this is pretty fast. Like 50% of the time, our user will have the response within 4 milliseconds. So yeah, we can say based on this data that yeah, our um, solution is real time. So what about the service? How are the services working? So how can uh, we verify the bottleneck? So if this is the Jaeger portal, we can see the applications that the microservices are listed here. Let's start with the API service. Let's see what took the most of the time to optimize our solution. So as we can see, the image search services took somewhat longer time. Yeah. So now we can dive into the image search service. So in the microservice, I also have a pprof based continuous profiler. To describe this, it will take much longer time, so let's skip. We can come back to the pprof application profiling later on. So let's see the embedder. Yeah, let's say the highest taken time. So we can see we have to improve the text embedding based on this result. Let's quickly verify some new ones. Yeah, as we can see, the text result generating text embedding is taking much more time than generating image embeddings. Yeah. Let's look at somewhat lower time. In the lower response times, so we can see the text embedding is taking much more time. So yeah, we have to we now know from the data that we have to optimize the text embedding. So this is how we can decide based on the data that we have. So yes, that was my demo. Hopefully, one last thing. We can deploy multiple versions of the application at once. Like if we refresh the page quickly, we will be able to see which. Let's create a incognito. Yeah. So we can see the variation here. So it's blue and greenish. We can log into the solution just like before. Yeah. So this shows how we can deploy the similar versions. Oh, also we can see the the UI's two versions like V1 and V2 is listed in the KLE dashboard, and we can see the traffic distribution from the dashboard as well. We can see 35% of the requests are distributed to V1, and 65% the traffic is distributed to V2. So this we can deploy canary versions of the similar application. We can also deploy regional deployments with the help of HTTP headers. Yeah, so my intention was to create a production like demonstration and and a way to improve the current solution. Thanks for the review. Let me know how what do you think, what other aspects you want to discuss more. Cheers, bye.